Hi, I'm Rich with insideHPC. We're here at the Intel HPC Developer Conference, and I'm here with Mike. And Mike, I understand that you do some work with FPGAs. Can you tell me about your role at Intel?
Yeah, that's right, Rich. I'm part of the Programmable Solutions Group at Intel, formerly Altera, and I'm an architect focusing on solutions for the data center.
Okay, so on that note, where are people deploying these things out there in the world?
Well, if you look at it by segment, in the cloud segment, Microsoft has said a lot about how they use FPGAs. Initially, they used it for Bing search. So when you go do a Bing search, that's being accelerated by Intel FPGAs. Then they talked about how they're accelerating their networking infrastructure, offloading virtualization. Then they talked about machine learning. And so they've talked about the multiple functions of the FPGA, and they've shared quite a lot for other people to see what's going on in the cloud. Now, there are other uses of FPGA in the cloud, such as Alibaba or OVH, where FPGAs are exposed to accelerate applications as a service. And in those examples, they've been talking about financial or genomics or machine learning or security or even video transcoding. So that would be the cloud segment. Now, in HPC, which is the focus of this show here at Supercomputing, it tends to be used for genomics or financial. They're also used in government to search for patterns, and of course I can't say too much more than that. And as well, emerging areas such as data analytics and oil and gas. And then finally, there's a traditional enterprise. Let's think about companies like insurance companies. And we have some very nice solutions lately in data analytics for those types of companies where the FPGA is completely hidden.
Well, Mike, I got to ask, because these FPGAs have had this reputation for being really hard to program. Is Intel trying to help with that?
That's absolutely true. So if you go back about 6 years ago, the only way really to program these FPGAs was to write RTL code, which is very complicated. It's almost like designing a chip, an ASIC chip. So about 5 years ago, we introduced OpenCL as a programmer's language. That's explicitly parallel, maybe great for people at a supercomputing show, but certainly not for everybody. So we've really been working to hide the FPGA completely. And so we're taking an approach of integrating to the many frameworks that Intel has in API libraries to completely hide the FPGA so that people don't even need to know what an FPGA is, for instance, to accelerate data analytics or even machine learning. So someone can develop a machine learning application using the Intel Deep Learning Deployment Toolkit and then accelerate it without changing anything with the FPGA. So in these examples, the FPGA is completely hidden.
Nice. Well, I wanted to ask you about the future. I mean, what's exciting to you about where these things are going and how they'll be used?
Yeah, so the wonderful thing about FPGAs is they're so flexible that they're always being deployed and showing up in new cases. So for instance, at the Supercomputing show, we were demonstrating first a newly announced Intel FPGA card called the Programmable Acceleration Card. And in that demo, we were showing how you could very quickly change between machine learning or compression or genomics. And then in another example, we showcased incredible machine learning performance by going to lower precision. So about 3 weeks ago, Microsoft announced at Hot Chips that 8-bit floating point is actually excellent for machine learning. And they showed how there's almost no loss in scoring accuracy using 8-bit floating point. Now, the wonderful thing about FPGAs is they're so flexible that if suddenly you want to start using lower precision floating point, well, our DSP blocks are flexible for that, so that's already supported. Other news, Stratix 10 is a newly shipping Intel FPGA family on the 14-nanometer fab at Intel. And we are showing at the Supercomputing show some very nice OpenCL compression using gzip or zlib of 18 gigabytes per second. It's pretty good throughput. And then lastly, we were showcasing recently NVMe over Rocky so that you can completely offload the processing to access storage. And we're showing on the host side an implementation where everything's completely offloaded by the FPGA, so very flexible for containers or whatever hypervisor you want to use. And then as well a solution on the storage side so that now you can inline, compress, encrypt, filter, really accelerate with that FPGA doing NVMe over Rocky.